Yeah, so here we go this afternoon then, and we're going to start off with Marco Perone, who's a software developer and mathematician and loves to code in the same formalism and precision you can find in maths. Yeah, interested in functional programming and how to introduce and apply its ideas in non-functional languages, domain modeling, which is awesome. So yeah, Marco's going to talk to us today about PHP heart emoji types. So yeah, let's introduce to the stage Marco. Hey Marco, how you doing?
Hi Gary, I'm doing fine. What about you?
Yes, not too bad now. Obviously a little tired now after eating too much at lunchtime, but all good. How are you going?
Yeah, I'm doing fine. Thanks.
That's good to see. So yeah, today you're going to talk to us about PHP and typing, and I'm guessing some static analysis libraries, right?
Yeah, sure. I'm usually using some, but yeah, you can choose your own favorite one if you like.
Amazing, amazing. So yeah, we'll let you get started. It's going to be a live talk, which I'm excited to see, and I'll catch up with you after your talk. So take it away, Marco.
Yeah, thank you. So welcome to PHP Loves Types or PHP Hard Types. I'm Marco. I'm a software developer in a company called SoEasy, and I'm working with PHP for quite some time, I think. And I started with version 5.2 of the language. And back then, the relationship between PHP and types was not that awesome. And PHP was, on the other hand, kind of known around for not having a good relationship with types. So mostly because it had some weird behaviors due to its dynamic nature. So for example, if you ask the PHP language if the string 7.10 is contained in the array containing the string 7.1, it will say true. Or another kind of unexpected behavior is if you take the string containing the Z character and you pre-increment it, what you get back is the string containing the two characters AA. And also, if you take this three string, you can see here in the slide, you can actually break transitivity of the less than order relation. But luckily, with time going by and new versions coming out, the relationship between PHP and types started to mend. They started to become more acquainted and even a little bit friends, I should say. It all started with PHP 7.0, I think, when we got scalar type declarations and return type declaration. Then in PHP 7.1, we got the nullable types, void functions, and the iterable pseudo type. With PHP 7.2, we got the object type. With PHP 7.4, we got type properties and return type covariance and argument type contravariance. In the current version of the language, PHP 8.0, we also have union types, static as a return type, the stringable interface, and support for mixed type. And with the future version of the language, PHP 8.1, as we saw this morning with the direct talk, we will get also enums and never return type. And hopefully with even future versions of the language, we will get even more niceties regarding the usage of types. But speaking about types, the first question which should come to mind or could come to mind is, but what are exactly types? So probably every one of you listening to this talk is used to declare some parameter type or some return type of a method. And so we know that we can say that the type is integer or string, but what do we actually mean when we talk about types? Well, from my point of view, types are basically a way to specify the meaning of values. So what you do is just take some values, collect values which have the same meaning, and give a name, basically a type, to this group of values. And speaking about meaning, I think that there are two perspectives that talk about meaning here. So there is one internal perspective, and that amounts to looking at the meaning of something as the operation we can perform on that thing. So basically, on the collection of operation we can perform of a certain value. So for example, if we have integers, we know that we can perform addition on them. So if we have two integers, we can get their sum because they are integers, and that type allows us to perform the sum. And also, if we have a customer type, a class, hopefully we might want to ask what the first name of a customer is. So we probably will have a get first name method on that class. And the whole collection of the operation we can perform on a value basically gives its type the meaning it has. The other perspective is more internal of a value, and it is looking at the properties that a single value should have. And by properties, I mean invariants. So things that should be true from the very start of your application till the very end. And types are really good at encoding and enforcing this invariant. So this is exactly what they are there for. Just to give some example of invariants we might like to have in our application, we can have, for example, we might like to state that an item in our e-commerce must have a positive price, or also we might like to ensure that the password in our application should be at least 8 characters long. These are properties invariants that we might want to have guaranteed to us by our system. And since we want these properties to be invariant, so to hold from the very beginning, what we should do is we should strive at best, our best, to force these properties by construction and not only by runtime validation. Because when I say runtime validation, I mean first you build something, and then in a second step, you check if some properties hold for that value. But if we do this, we first allow to build things in an invalid state. So the mantra that you should have in mind here is make illegal state unrepresentable. So if a state does not make sense in your domain, there should be no way to build it in your application. So if now we have a kind of broad definition of what types are, the next question we could come up with is why should we use them? What do they give us? What's good about them? So the most sold property, I think, of types is that they are good at catching bugs. And I should say they are very good at preventing bugs to happen in the first place. Because if you know that a method is returning, I don't know, an integer, and we pass that return value to another method, which is requiring a string, we know that something will not work correctly there. So just by checking if types align, we can prevent some bugs to happen. And I think that this ability of types of catching bugs is just a side effect of good domain modeling. Because if you are able to encode in your domain, in your types, a lot of invariants, a lot of properties of your values, then it comes natural to use your values only in a correct way. And since it's easy to check if types align, well, easy, I mean, in between quotes, but it's kind of fast. It's faster than running an application and check if that actually works. What we get is we get fast feedback on whether the invariants we are encoding in types are respected or not. And so we can have this kind of IDE experience where as soon as we type, we can get some immediate feedback on whether what we wrote will work or not. And since we have this fast feedback, types help us a lot during refactoring steps, because if the type checker tells us that some types are not aligned, then probably our refactoring is not over. There's still something we need to fix. And once all the types are aligned, probably we are done with our refactoring. So they are really a nice guide throughout the refactoring processes. And another property I really like about types is that they are really safe. So once you encode a property in there, then the property will hold for sure. That's basically the same thing as saying that a type is as convincing as a proof of a mathematical theorem rather than uh, uh, just a basic example. And this intuition of types being related to proof is not just a suggestion, but it's actually something very concrete, which is backed by some strong mathematics. And the main result there is the so-called Carey-Howard correspondence, which basically says that type theory, so the study of the usage of types in programming language, is strictly related, corresponds to proof theory, which is the part of mathematics which is studied by logic and looks into how do we reason, how can we make correct reasoning. But let's stop here with this possibly abstract nonsense and let's have a look at something more concrete. So let's start looking at what do the type system of PHP provides us. So in PHP, we have basically the language gives us two families of types. One is the native types, which always come in any project, which are divided into scalar types, which are Boolean, integer, floating point numbers, and strings, compound types, which allow us to put together simpler values, which are arrays, object, callables, and iterables, and some special types, which are resources and null. The other family of types we can have in a PHP application is basically the user-defined types, so which are classes and interfaces. So each time you define a new class, a new interface, you're adding a new type to your type system, you're enriching your type system. And since one of the reason you use type is to encode meaning of things as we said earlier, what you could use type for is to encode properties of your domain. So what I like to call them is to call these like domain-driven types, and they basically correspond to what are referred to as value objects in the domain-driven design community. And it's just a way to convey more meaning using the type system. So let's think at a concrete example. If we have an integer representing the age of a user, of a customer of our application, we could treat that as an integer, but not every integer is actually a valid age. For example, I never met a person who was -5 age. And so what you could do is you could wrap that integer into an age class to guarantee that that age will be positive. So every time somebody else in your application meets this age class, it will know that the integers contained there will be something which is valid to represent an age. Same thing, for example, for a job description, not any string represents a job description. So we could use this kind of new types that we define to express and restrict concept from our domain. And this is basically, so the native types and classes and interfaces are all the types we could have with the basic version of the PHP language. And I should say that this is, well, it works as a type system, but it is not very powerful. So what one might like to do is to expand it. And there are some really clever people who did this in the PHP ecosystem, providing several libraries, basically static analysis libraries, which allow us to expand our type system. Today, I'm going to talk to you about Psalm because it's the library I'm generally using. There are several other projects similar to Psalm which basically do the same thing. So you just can choose your favorite one. And how does PSAN work? So basically, it's a type checker. You annotate through real annotation your code, providing information about the types of the object of the values which go through your application. And you can put annotation in several places, for example, at the class level, at the class property level, at the method level, stating the type of the inputs and the return types of any method. And in this way, you basically provide information to PSAN, and then you can just go to your console and run PSAN as a static analysis tool. And what you will get back is just basically a list of errors or of failures of things that your application is not respecting. So this that you see here is the list of errors regarding the code I showed you in the previous slide. And it's basically saying that we had a method which had the return type declared, but it was actually not returning anything, and that we had two properties of a class, but they were not initialized in a constructor. Okay, so this is basically how PSAN works, but what does it gives us? So how does it expand the type system? Well, in several ways. It gives many ways to be more precise when we deal with scalar types. For example, it allows us to say that an integer is actually positive. It allows us to say that the string should actually contain the name of a class, the name of a trait, or should refer to a callable, that the string should actually contain a numeric value, that a value should be something that we could use as the key of an array, that the value should be something numeric that we could do some arithmetic with, or that should be something, just any scalar value. It also improves the array type, because the array type in PHP is very generic. You can make a lot of things with it, but you never know which thing in particular you are doing with it. So PSAN gives us a way to be more precise. And for example, it allows us to say that an array should be non-empty, that an array should contain elements all of the same type, or that an array should contain values which have the key of one type and the value of another type, that an array should actually be a list, which is something which has keys 0, 1, 2, so on and so forth. Or on the other hand, that an array should actually be used as an associative array. So we have fixed keys, and for each one of those keys, we have a value of a specific type. Or also we could use an array to specify a callable, and we can provide that information to PSAN. Speaking of callables, another thing you can do with PSAN is to improve and be more precise when you deal with callables, because the PHP language in itself, you can just say, this thing is a callable, but you don't know which input and which output it will deal with. With PSAN, you have a notation to make that explicit. Another thing you can do with PSAN is declare union types for versions of the language where union types are not there yet. So if you're working with PHP 7, you can still use union types. And the best thing from my point of view that you get with the usage of PSAN or similar libraries is the usage of templates, which are also known as generic or type variables, depending on the community you talk with. And you might know them from other object-oriented languages as Java or C#. And what you basically do, you can basically tag your class with an annotation template, which basically gives you a space where you can put a type. So you write your class in a generic fashion, and then when you want to instantiate that class, you can say what that a template should actually be. So for example, in this example of a repository, so just a collection of values of the same type, we have this a template, and that a, remember, should always be the same through the same instance of this class. So when we do a find, when we execute this find method, we will get out either null or something of type A. And when we add something to the repository, we will be able to add only things of the same type A. So this is a way to force that a single repository will deal with values of the same type. And then when we want to create a new repository, we can, for example, declare a user repository like this and annotate this saying that this repository will deal only with users. And this is very nice because it allows you to write more generic and more reusable code, which is always nice. Okay, now this is basically what Psalm gives you, the feature it allows you to use. And now I'd like to present you some more concrete usages of this feature. So let's juggle some code and let's look at two concrete examples. So the first one I'd like to talk about is validation. So validation is basically a procedure where you get a value and you check if some property hold for this value. And encoding the fact that the property hold for value is what we said types are good at. So I really think that validation is a great place where to put types at work. So let's start with this, and let's start by drawing a simple model of what validation is. So for me, validation is just, well, taking an input value, let's say it has type A, passing it to some kind of validation procedure, and then getting back either the value or some kind of failure. So the validation has two possible outputs. Either the validation succeeded and we got back our value, or the validation failed and we got back some error message explaining why the validation failed. This is nice, but it's not the best model from my point of view, because what we could actually do is we could change the type of the result in the success case. And why should we want to do this? Well, that's because we want to encode at the type level the fact that we now know more about the value that we receive in the input. For example, if the input is just any integer and the validation is check if that integer could represent the age of a user, so it should be a positive integer, then in the valid return case, so if the integer was actually positive, we don't want to return just an integer because we will lose the information that that integer is actually positive. But what we might want to do is to return the age type I presented in a previous slide, which encodes the fact that that integer is actually positive. And the key idea here is called, well, it's famous, known around as parse don't validate. And this is a link to a great blog post by Alexis King that I really recommend you all to read. So now we have this quite simple model, and let's try to translate this into working code. So let's begin, and let's define an interface, validator interface, which will have a single method, validate, which will take some data as input. And we are using a template for the type of data because we want that type to be generic, but we want to be able later on to specify which type that A is actually. So for example, we might want a validator which take an integer as a parameter, or another validator which take only a string as an input. But the question now is, what should the return type be? Because we know that we have these two cases. How can we model that? So before going into the code, let's try to think which are the invariants we want to hold true for the return type of a validation procedure. So the first thing we know we would like to have to be is that the results should be either valid or some errors. And with this, I mean that there should be these two possibilities, but we want to avoid the possibility that there is also a third one. So there should be only two and no more. Also, another invariant, another property we would like to have is that we would like to create an API which forces the client of our validation result to process every time both the valid and the errors cases, because it's generally too easy to forget to handle error cases. So we would like to force our clients to handle also that case. And the third thing we would like to enforce is that the relevant information is only accessible in the relevant case. So with this, I mean, we should be able to ask for the result of validation only if the validation succeeded. And we should be able to ask for the error messages only if the validation failed. So let's see, with these properties, these invariants in mind, which could be some ideas which we could put into play to model such a return type for our validation. So the first idea which could come to mind is just use exception. So how would that look like? Well, we would have our validator interface with our validate method, which is going to take an input of type A and return something of type B, which is the type of the thing that which we return if the validation succeeds. And if the validation fails, we just throw a validation failure exception. So this option using exception to me has two flaws. One is more semantical, that I don't think using exception for a thing which is pretty much to be expected, like the fact that the validation fails, is not their place to be. So exceptions should be more used for exceptional cases. And also the other thing I don't particularly like about this approach is that, well, exceptions are not traced at the type level. So we have no way to track at the type level what happens if the validation fails. So for these reasons, I would like to cross out this option. So let's try to look at another one. And another one option we could come up with is the usage of a method called isValid. So we just define a class validation result with an isValid method, which returns a Boolean telling us if the validation succeeded or if the validation failed. And then if the validation succeeded, we could ask for the result of our validation with a getResult method. And if the validation failed, we could ask for the error messages using an error messages method. With such an approach, we are not satisfying the request we made at the beginning, because, well, we are providing access to the result and to the error messages in every case. As soon as somebody has a validation result, even before knowing if the validation result is valid or not, it could try to access the get result and the error messages. And also, we are not forcing the fact that the client handle both the valid case and the failure case, because what could just do, if it's valid, then get result and go on, and forgetting to handle the failure case. So this is also not satisfying the request we made in the beginning. Another possible option is use inheritance. So have, for example, a validation result interface with two concrete classes implementing that interface, validation success, validation failure, describing basically the two cases that we can have. So this approach allows us to say, okay, the result is only accessible in the validation success class, and the errors are only accessible in the validation failure class. But what we are missing here is the fact that this allows us to define a third case, because inheritance is an open concept. There's no way to force inheritance to stop at a certain point. So we could, or any client of our validation result library could just define his own version of validation result implementing our interface. And so at that point, we will not have just 2 cases, but we will have 3 or even more. And so also this option is something that we discard for the moment. Let's look at the fourth one, which is using union types. And so we go back to our validation interface. We have our 2 templates, one for the input and one for the output, basically. And we say that the validate method is taking an input of type A and is returning either validation success containing something of type B or a validation failure. So this forces the cases to be exactly 2, but still it does not force the client to process both cases. Also, what one could do if validation result is instance of validation success, then extract the result and go on, forgetting to handle the failure case. So also this option does not satisfy the request we made in the beginning. So now you might wonder, is there actually a way to satisfy those requirements, or were we asking too much? Well, if I mention them, probably it's because I had a solution in mind I wanted to show you. And good for you, that's exactly the case. And one possible way we have to implement a class satisfying those requirements is as we are going to see now. So we introduce a validation result class, which has a template A for the value it will actually contain. And then we disambiguate between the 2 cases, validation, a successful validation or a failed validation, with having 2 separate constructors. So we will have a constructor called valid for the success case, and this constructor will only take the valid value, and another constructor called errors, which will be used for the failure case, and it will take as input only a list of error messages. And then to force the client of such a class to handle both cases, the API that we provide them is as follows. So we provide a single method process, which requires as input 2 callables. One, which will be invoked if the validation is a success, and the other callable, which will be invoked if the validation actually failed. And the first of the 2 callables will have as an input parameter only the valid result, and the second callable, which will be called in the failure case, will have as input only the list of error messages. So then when a client of a validation result wants to process it, well, it calls this process method, passing these 2 callables. The first one, which will be called, as I said, in the success case, and the second one, which will actually be called in the failure case. And in such a way, we were able to provide access of the relevant information only in the relevant case, and to force also the client to handle both cases every time. And also, since we are in control of how many constructor we have in our class, we're also in control of how many cases that could be. So, and we are stating clearly that at the moment there are just 2. So this is a way to encode, I would say, in a single type, which is this validation result, and in its API, the invariants we described before. So I think this concludes this particular example. I'd like to discuss a further one, which discusses the so-called phantom types, which is a kind of a funny name, but they are quite simple concept. So let's go back to the repositories we had previously. So imagine this generic repository class indexed by an A template, and we had this find method, which was taking an ID as a parameter and returning either null if nothing was found for that ID, or a value, an instance, an object of type A. This is good because we have a generic class, but still it's not as type safe as we would like it to be. Why? Because, well, this could happen. We could have an ID and a generic ID, and we could use the same ID for different repositories. But usually in our application, when we have an ID, we know that that ID will be an ID of a user or the ID of an order. So it usually does not make sense to use the same ID with different repositories containing objects of different type. So one approach we could have used even before we had Psalm and similar tools was just using inheritance and extending our ID class with more specific types. For example, we could have a user ID type or an order ID type. But if we go down this path, we basically lose our nice generic repository, because if we want this approach to be type safe, then what we need to do is to have a single repository for each type. So we need to create a single class user repository, another class order repository, and so on and so forth, losing the single nice implementation of the generic repository. So how can we get back the generic repository and still have the type safety that such a solution could provide? So the trick is quite simple. We just add a template annotation to the ID class, and this will allow us to specify that an ID refers to a particular class, to a particular type. And this A template here is called the phantom type because there's nothing actually inside the ID class corresponding to it at the value level. So at the value level, that A template doesn't mean anything. It is only basically a tag information we put at the type level. But just by doing this, it allows us to slightly change the signature of our find method in the repository, and saying that the find method does not accept a simple ID, but it needs to accept an ID of A. And the A, you remember, is the type of the values contained in the repository. So we need to use an ID that we already know refers to one of the items possibly contained in the repository. So then when we want to use this, we just declare an ID and we tell Psalm that that ID is an ID of a user, for example. And then when we try to use this with the user repository, well, everything works fine. But when we try to use such an ID with an order repository, well, Psalm will complain. It will basically prevent us to do such a thing. So in this way, we were able to get back our generic repository, and also we were able to get some nice type safety. So at this point, I am basically done. I would like, just to wrap up, saying that types are a great tool to encode properties and invariants of your application. So as soon as you see a possibility to encode some property in a type, well, just don't hesitate, go for it. It will repay you in the future, because too many times I saw weeks of debugging saving people from an hour of type modeling. And with this, I'd like to thank you, and I'll be happy to answer questions if there are any.
Thank you, Marco. That was awesome. Yeah, we have a couple of questions, so I will field them to you. There's a question from the chat asking what SAM level you suggest using. I know that's a very generic question, but it's an interesting starting point for a discussion, right?
Yeah, sure. So my approach, what I like to do is to start with I think that Psalm, the level 1 is the toughest one, so the one which catches most, controls more things. And I mean, for new code, I definitely would recommend to check more things as possible, to be strictest as possible. If you have a legacy code base and you want to start introducing Psalm on it, then you could maybe start with lower levels, higher levels, we check less things, and then increase as you go on. Also, another cool feature that Psalm has is that you could have, you could basically make it run once and say, okay, I have all these errors now. Okay, don't report these errors to me anymore. Just report to me only new errors I will do from now on. And that's fine. That's how, for example, we are using at my company now. And one nice thing I saw that even though we have really a bunch of type errors hidden, we are actually correcting them as we go along. So as we get used to use Psalm in new code, we are also brought to correct type annotation in legacy code. And so we basically improve also the typing over there, even though Psalm does not ask us to do so.
Gotcha. So you set like a baseline of errors and say, right, we're not going to let any more errors be introduced, but we are going to try and reduce the number of baseline and not allow those some type errors in any new code. So yeah, I think like I've started trying to use SAM quite a lot when I'm just, I don't really do code that ships to production anymore, unfortunately. Working at Twilio, I just write little demos and sort of throw some code together for a bit of fun. But I've really been starting to try and sort of use SAM level 1 because it just picks up stuff as you're writing it, right? But I guess the hardest part here is not with sort of greenfield new code, but what what can you do if your existing dependencies are not well typed, for example, in a legacy project? Is there ways that you can tackle that with SAM?
Well, you could certainly contribute to the open source and add some annotation to some other projects. And well, what you can do if a project does not support Psalm, you can just suppress certain errors, because there are some times where you know more than Psalm, and so you just want to tell Psalm to basically shut up. I know best, and you go on with it. But yeah, I think that trying to contribute Psalm annotations or PHPStan annotation should be the same. Very common libraries should be something that the community should be very much involved.
Yeah, I agree. And how does this kind of mentality of thinking about types and being, mega strict with typing work if you're working with something like a Laravel application? Laravel's the arguably the most popular framework at the moment in PHP. And is this something that plays well with a more like opinionated framework like Laravel?
Well, I haven't had the luck to work with Laravel, so I cannot relate some first-hand experience. But I know that, for example, PHPStan has a specific version built for Laravel, which is called Larastan, which basically takes into account all the conventions which Laravel project uses. So using that is probably the best option if you're using Laravel. So having basically a static analysis tool which understands the convention that you're running with.
Gotcha. A question from the chat. Would Marco like to have a project where primitive types are only in value objects?
Sure, I'd love that. I mean, if there's something where I have more properties on a value than being an integer, which is generally the case, I'd like to have it. One of the things I recently did at my company was just writing bunch of value objects just to wrap the native values, and I think that gives a lot of value to an application and to domain modeling.
Yeah, I guess with the advent of what we learned earlier from Derek with the PHP 8.1 and enums and other stuff coming in, like and the immutable, the way that we can build immutable objects now by saying, right, we can only get with these properties. I'm only seeing more value objects in PHP's future, if I'm honest.
Yeah, well, also another thing I forgot to mention, because it's not strictly related to types from some, is that you have an immutable annotation that you can provide on a class, and it basically checks that you're not using any mutability in there. And yeah, I would really love to see enums even expanded more up until algebraic data types, which is, I guess, the next natural step. So also, yeah, that's it.
I think we got time for another question. Marco Pivetta asks, what is, in your opinion, the hardest part of introducing SAM to a team?
I guess the hardest part is just convincing developers that that is a useful tool. And I think it's not super hard if it doesn't get too much in the way. So what I would suggest is probably start to run it without making it compulsory. So maybe putting it in CI, but not making pull requests to be, being able to merge pull requests even if you have some failures, so that people could still read the output of Psalm, but they are not blocked. So that could be a starting, so they start to be familiar with the tool. And then a bit by bit, you maybe start introducing it just in a small portion of your code. And you say, okay, this part of the code is protected by Psalm. So if you deal with it, you need to just to pay attention to it. And then a bit by bit, expand it. What, for example, I saw in my team when I joined, I basically said, okay, I want to use Psalm because I'm basically no more able to write PHP without it. And my colleagues at the beginning were a bit, you're sure? It's kind of a big step. It's kind of different for what we are used to. It forces us to check many more things. And after some months, everybody was basically enthusiastic about the tool because it allows us to prevent a lot of bugs. And it helps you also a lot in thinking and domain modeling, which is, I think, the hardest part when we do coding.
Yeah, I think the first time you find a bug that will be affecting production and costing the company money, use it, because there's been some kind of type failure, is the time that everybody goes, oh, we should have been doing this since forever. So yeah, I totally agree with you. Awesome. There's a lot of love for SAM in the chat, which I love to hear, and a lot of discussions around value objects. But I'll say thank you so much, Marco. That was amazing. Yeah, when I see these amazing tools, I'm like almost jealous of the fact that I'm not writing production code anymore, because it makes it so much easier. But that was awesome. Thank you so much, Marco. And yeah, thanks again.
Thank you. Thank you. Thank you, everyone.